the total friction is now equal to 200 plus 400 sin 30, which will give us 200 plus 400 times 0.5, which will now give us 400 Newton. Example 6. A parcel of mass 4.5 kg is suspended from a spring balance in a lift. What does the balance read if the lift is moving with a uniform speed, accelerating upwards at 0.5 meters per second squared, accelerating downward at 0.5 meters per second squared, taking force of gravity G equals to 9.8 meters per second squared? Solution. Mass is equal to 4.5 kg. Acceleration is equal to 0.5 meters per second squared. Gravity is equal to 9.8 meters per second. Then the tension T is equal to mg. Therefore, tension is equal to force, which is equal to 4.5 times 9.8, which will give us 44.1. B. Mg minus T is equal to Ma. Then mass, which is equal to 4.5 times acceleration due to gravity, which is 9.8, minus T is now equal to mass of 4.5 times 0.5 acceleration. 44.1 minus T is equal to 4.5 times 0.5. 44.1 minus T is now equal to 2.25. T is equal to 41.85. Example 7. A mass of 4 kg rests on a rough table whose coefficient of friction is 0.4. Find the least force sufficient to make it move. Take force of gravity equal to 9.8 meters per second squared. Looking at the figure 1.9 example, a mass of 4 kg is being slided by a force of capital F, and it is resisted by the small f. Then the reaction, which is normal to the body, is R, which is equal to mass times acceleration due to gravity, which is 39.2, and the reaction, which is normal reaction, which is mg. Solution. At sliding force or resistance force, small f is equal to coefficient of friction mu times resistance normal reaction R. Therefore, but mu has been given to be 0.4. The reaction R, which is equal to 4 times 9.8 meters per second. Therefore, the sliding force F is equal to 0.4 times 39.2. Therefore, sliding force will now become 15.68 Newton. Example 8. If a force at 10 Newton is just sufficient to move a mass of 2 kg resting on rough horizontal table, find the coefficient of friction taking force of gravity G equals to 9.8 meters per second squared. Looking at the diagram, a 2 kg mass is being pulled by a 10 Newton force, and small force F is resisting the pull. If the normal reaction acting on the mass is 19.6 and the weight of the mass is mg, then we have that the solution, limiting frictional force is equal to resistance force. Limiting frictional force is equal to coefficient of frictional force times normal reaction. its limiting frictional force has been given as 10, which is equals to mu coefficient of friction times the normal reaction, which is 19.6. Making coefficient of friction the subject of the formula, we have that 10 over 19.6, which will give us mu as 0.5. Example 9. A block is placed on an inclined plane at angle 30 degrees to the horizontal and just remain at rest. Find the coefficient of friction and the angle of friction. Looking at the diagram, a force F is pulling the body, which is having a smaller resistance frictional force. Then the normal reaction R will be acting at a 90 degrees angle. Then if you have to draw the resolution from where the force is being pulled, it will now form a right angle triangle, and from the body of mass. We know that limiting frictional force F is equals to coefficient of friction mu times normal reaction R. Making mu the coefficient of frictional force the subject of formula, we have that limiting frictional force over normal reaction. Therefore, tan theta is equals to limiting frictional force over normal reaction. Tan theta is still equals to the coefficient of frictional force. Therefore, tan 30 is equals to the coefficient of friction. Solution B. Looking at this body on an inclined plane of 30 degrees, assuming a normal reaction is acting with mg cos theta, then the force dragging the body down is mg sin theta. Force is equals to F is equals to F. Therefore, mg sin theta is equals to mu mg cos theta. Therefore, making mu the subject of the formula, we now have mg sin theta over mg cos theta, which is equals to, if you do our calculation and cancelling the m and the g, cos over sine over cos is a tan theta is equals to mu. Therefore, tan 30 is equals to mu, which means that mu coefficient of friction is equals to 0.58. Example 10. A block of mass 10 kg is placed on an inclined plane of angle 30 degrees to the horizontal, where mu is equals to 0.5. Find A. The acceleration of the block down the plane. B. The least force parallel to the plane required to keep the block at rest. C. The force required to make the block begin to move at the plane. Taking G, acceleration due to gravity equal to 9.8 meters per second squared. Resolving the force of the body on the inclined plane, we have that the body of mass 10 kg is being pulled by a force mg sin theta down the plane, and the resistance force small f is trying to pull it up the plane. Then the normal reaction pulling the body down the inclined plane is equals to mg cos theta, and the weight of the body is mg. We have been given that mu is equals to 0.5. Solution to find A. Force, limiting frictional force, is equals to resistance force small f. Force normally is equals to mass times acceleration. Mass times acceleration due to gravity sin theta minus force